Yeah, hello everyone. Actually, welcome to the Azure Developer Community, the Coimbatore branch meetup. Actually, today we are going to host a session about the Azure Kubernetes services. Now it's about my speaker actually Vignesh Sankaran, who is having a 5+ years experience of in the IoT domain with yeah, extensive knowledge in Kubernetes and Dockers actually. And actually, he's having yeah, currently working as the senior business analyst in in actually the organization name called HCL. Vignesh, actually, it is your stage now. Yeah, kindly share your screen and you can present the presentation and you can go ahead from here actually.
Thanks, Arun. Thanks, Varun. Hi, all. Welcome to this session on the Azure Kubernetes services. I'm Vignesh, and I have 5 years experience in software industry. And let's go on to see what Azure Kubernetes services is. This is the agenda for today. Let's see what Kubernetes is, how the evolution of SDLC has happened, and why we need Kubernetes and Azure together, and what are all the customer stories. And we will finish up with a small demo. As you see, Azure Kubernetes. What's Kubernetes is mainly, you see, Kubernetes is a container management service. It was developed by Google in a language called Golang and donated to CNCF. Then from there on, it's an open source to everyone to use. So Azure, what Azure did is Azure as a cloud service provider, leading cloud service provider, which has a very big community, has taken up this service and integrated with its platform so that we can directly go for a serverless, continuous integration, continuous deployment experience. Hope I am audible. Am I audible? Hope I am so. Like, let's see what Azure Kubernetes has achieved till now. By 2020, it has been said that more than 50% of the enterprise will run on mission critical containerized cloud native applications. Containerized cloud native applications. We will see more about it if you are a fresher. Like, if hope you all are aware of about the development of software using software development lifecycle. If you see, these are the various strategies which we used during this period of developing a software. Like, first was a waterfall. In waterfall method, if you see, we used to create every application in a single platform. I mean, in a single container as a single application. This we will gather the requirements, then we will go on to develop the application, maybe for a period of a certain period, then after which it will get uh, delivered to the customer. Only then we will get to see how the application is, and is there any changes to happen. So these had many downfalls. Then as time goes, we adapted agile method. In agile method, we used to see more of a sprint wise development. And then we adopted DevOps. Why we adopted DevOps is mainly because of the microservices and granular chunks of applications which we can directly intervene if something is not working in it. And then we can we were able to more reverse engineer with it using DevOps. So we can classify these strategies based on these three uh, structures, like application architecture, application infrastructure, and deployment. If you take an application architecture, during waterfall method, we were more into a single application, which I already told about. Then once we went into an agile method, It's more of a multi-tier application where database used to be in a different tier and front end used to be in a different tier. Now it is further classified into microservices and granular part. Now we are coming to the deployment area where in waterfall we were mainly dependent on physical service. So mainly dependent on physical service. Once we moved on to agile, it's more of an virtual service, and then we adapted now what we know as the microservices and the containers in DevOps. If we take an application infrastructure, if you see in waterfall, we used to depend more on the data centers. Once we moved on to agile, we were dependent on hosted platforms. Now, once these cloud service providers have come, this is where application infrastructure has gone more into a serverless need, where we are hosted into a cloud where we can directly enter the application from wherever you want. So let's move on. If you see as a Kubernetes, it's an industry leading orchestration tool because it is more portable and extendable and self-healing. What do you mean is that even in a cloud service, it can be mainly, see, if you're using an application which is being hosted to a cloud, suddenly if there is a huge surge of traffic, there can be many people entering the application, accessing the application. That's when you need more instance of the same application to be accessed by everyone. So there we need to have a load balancing or a scalable application. That's where this auto scaling, auto replication helps. So that's what provided by the Azure cloud platform. So once we see how Kubernetes works, one second. So if you see Azure and Kubernetes, both have combined together to form this Azure Kubernetes, where if you see Azure user can communicate using an API server, and what we call as a master node is the main instance of a Kubernetes, which has a control manager, which has a scheduler and etcd. And using this API server, we will access this service. And once we access this service, this will create an instance of a worker node where you need to know uh, certain pointers like what is a pod, what is a kubelet, and what is a container. Container is nothing but a separate package where every application, I mean, whatever the resources needed for the application is being packed into this container and is being deployed. And kubelet is nothing but a service which helps you to access this application. And once we get into it, and this scheduler scheduler helps in deploying the application whenever needed it to be. And once control manager is nothing but let's say this application needs to be accessed with a huge traffic, then we need multiple server worker nodes, and that replication controller will be handled over here. This control manager is for that purpose. And then if you see from infrastructure to innovation, this Kubernetes, once it combine, if you use it as an alone separate one, we need to have we need to do it on our own for containerization, then continuous integration, this cluster hosting, and every other activity. But once it has been controlled by Azure, it can take over most part of it. Only the containerization and debugging and various other aspects which we need to make ready as this Docker image can be done over here. And talking about Azure Kubernetes services, This can be compared to a virtual machine. So to understand this Azure Kubernetes services, we can compare it in a way like for a, you might have used a virtual machine, where for a virtual machine, thanks Varun. Like now I am continuing with the presentation. Like for the virtual machine, if you see, we have a server. Over the server, we will have an hypervisor. Over the hypervisor, separate instances of that virtual machine will be used. For an each virtual machine, if you take, there will be a separate OS, and again whatever applications which you are using for that instance, it will be installed over there. But what is the disadvantage over here? These virtual machines will be very heavy. It won't be efficient enough. But comparing it to a Kubernetes services or a Docker or a container instance, where in a container instance, this server, this hypervisor, then OS, whatever guest OS which you are using, should be common to the every container which we are using over there. What it does is it will help in reducing the pa- package weight of the application which you are trying to access, and then this will help in accessing the information fast and getting whatever service which you are trying to access over there. So if you see, Kubernetes has a, once Azure adopted this Kubernetes, it has a very big community over there, which is a great advantage because there are many more users who are trying to access it and trying to find some other faults and trying to bring up new applications and patches which will help in growing this community. So that's it. Then this is Microsoft's contribution to the community on packaging distribution, scalability, and Kubernetes developers tooling, where they have brought up various other services. So mainly why we need to adopt Azure Kubernetes rather than Kubernetes is because Azure as a cloud service provider, they have adopted many other applications, say it like analytics or whatever you need to find about the application which you're trying to use. So this will give a added advantage of for anyone who is using an Azure Kubernetes, so that they can look out for their networking or whatever additional resources needed in Azure platform. So these are the contribution to the community as of now. So which shows that Azure Kubernetes is one of the leading containerization package tool used. So these are the various scenarios in Kubernetes where we can use it, and this mainly helps in cost saving and more of agility for faster application development and performance, and then portability and automation. So these are the various companies. So one such company, if you see, is Bosch. So Bosch had a particular problem where uh, they need to create a service which will inform their intimate their end consumers if they are trying to drive in a wrong direction. So if that is the scenario, see, if a person is driving in a wrong side of the road, this has to be tracked using GPS and various other tools. From there, that data should go back and get processed, and then he has to be intimidated that he is going in a wrong direction. So this is a very long process and a critical one, but it has to be done in a very short period of time. So that's when Bosch brought up this Azure Kubernetes services. They collaborated with them and they brought up an application where, if you see that particular service will reply back to the end consumer if they are taking a wrong direction in just within milliseconds. So let's see the demo once again. So we just need to give certain commands and we'll be done deploying that particular application. For this instance, I have just taken a code from Azure samples and I have saved it into my desktop. From there, I have also installed this Docker engine. Then hope we have to check whether this engine is running. After that, we have navigated to that particular folder where where we will now create a Docker image for that application and we will deploy it. First, we will deploy it in First, we will deploy it in our local and we will see whether the application is running. Then we will deploy it to the cloud platform, that is Azure. Then we will see that also. So for that, if you see, this is the portal for the Azure portal, which you can register and get. And if you see here, this is the Kubernetes services which we will be using. So first command which I will give for this Docker is Docker compose different. So this particular application is getting a Docker image, where this Docker image is almost like a ready-made version which can be pushed into the platform and which will be in a format accessible for the services to be. So meanwhile, what we can do in this platform, if you see, we need to create a particular resource group so that something similar to that of a one second. Is my screen visible?
Sir, if you are saying something, you are on mute. Okay.
Yeah. Like, is my screen visible? Like the Azure portal is visible over here. So if you haven't seen this one, I just gave a command called docker compose up hyphen d, where this particular Docker image gets ready from the application which we have downloaded, and it is ready. It has created this Docker image over there. So meanwhile, what we are trying to do is we are creating a resource group in the Azure portal, which we can use it for our activities. This can be considered as a separate folder where all the resources needed for the demo will be listed. I just gave a command called Docker images to see whether what all the images has been created for our application. Once This is the command prompt area where I just I just created a Docker image for the application which we have. I just navigated to the folder, then I just gave this command, and then this created a image which is a Docker image, and giving this command we will see the Docker images which has been ready. Now in this portal we can create this Kubernetes services which we are trying to access.
Sir, actually your portal screen share is not visible.
One second. Confirm that whether my if I share the screen over here,
Yes, sir, I
is it
think, yes, sir, now it's visible.
and whether my command prompt is also visible?
So can you please switch to the command prompt?
Yeah, I am in command prompt. Whether is it visible now?
No, sir. Actually, only your StreamYard and Google Chrome is visible right now.
Okay, one second. In that case, whether I have to share the how to share like my entire screen?
Sir, on the share option, you must be getting an option of share screen, and then it will ask you that you want to share your
I have
entire
shared
screen
my
or
entire
window.
screen now. Yeah, I've shared my entire screen now. Whether
So
my
you,
Docker?
yeah, now it's
Yeah.
visible. It would be great if you could please zoom in a bit, and we are good to go.
Okay. Now, hope I'm fine. So if you haven't seen before, I got into the command prompt where we access the folder where we downloaded the application. I'm audible. Yeah. So there, once we navigated to that folder, we gave this command, particular command, and what happened is that this Docker has created an image, and this Docker image has been listed over here. Now, what we are trying to do is getting into the Azure portal where we are trying to create a Kubernetes cluster. So for that, I am selecting this resource group. We can give the name, whatever name we want. So it will list the node pools, the authentications, and various other. And once we give review and create, it will create our cluster. So I'll give create. So it is getting deployed. Meanwhile, which are the Docker images for that application which we created. So once we create that, we need to log into that. One second. One minute. Now we need to create a container registry in our Azure portal so that whatever image which we have developed can be pushed into this container registry. So yeah, this is the resource scope which we gave, and for that container registry we can give. So we will create this particular registry container. So it is getting deployed. Under this resource group. Hope I am audible. So now we can access this particular. Container registry. So it has logged in into that registry. Now we can so this particular registry has given us a server using which we can push our image. One second. Hope my screen is visible. So what we will do, we will push that image. First, we need to tag that Docker image with this container registry. One second. What I have done in the previous mistake is that I have given a wrong command over here. So right now this is getting pushed into the repository. But as you see, once again, See, once I have created that image, I am not able to push it into the registry. So I think,
So, guys, I think there is some kind of technical issues with our speaker, and we are really sorry for the inconvenience to all of you. And we are also unable to do anything. Actually, there is a technical issue uh, for his internet connection, and he's unable to conduct the session right now. So let's postpone this session. We have conducted the session up to very up to the very much part which the speaker wanted to show, but for the wrap up part we'll try that we just once again reschedule the session for you all, so you people all can start learning from the very scratch. So till then you guys can take care. You guys can learn more things about from the documentations in the other part like YouTube or internet. And then when we reschedule the session, you guys can please ask your queries if you have any, and then the speaker will do the hands-on part as well. Thank you guys.